Let's talk about the print function. It's pretty simple and straightforward, and we're going to use it a lot in our code examples. It's basically the simplest way to get output on a console window. Now this actually should be a lowercase p print, but this function takes a parameter. Actually it can take multiple parameters separated by commas, in which case it concatenates them together in the output. But for example, this string here, hello world, would be displayed on the output. Indenting of code is how Python is able to define blocks of code. So unlike some languages that use curly braces, examples would be C, C++, Java, and C#, and unlike other languages that use keywords for this purpose. So Python just simply uses indentation to accomplish this. What about case sensitivity? Well, yes, Python is case sensitive. What about something simple like swapping two variables? Well, here we see how we do it in Python, x comma y equals y comma x, and this might look surprising. So in a lot of other languages, you would probably have to have a temporary variable. You could assign x to a temporary and then assign y to x and then assign y to the temporary. But although this looks a little bit strange, you can actually have multiple items on the left of an assignment, multiple items on the right of an assignment, separated by commas. Okay, so let's take a look at doing a simple demonstration of some straightforward Python syntax. So let's get started with some of the simplest aspects of Python syntax. And in order to study that, we're going to take a look at a few of the code examples that we have here. So some of these are more lengthy topics, and we'll postpone those till just a little bit later, and we'll go into more detail on some of those complex topics. And but for now, what we're going to do is just first of all take a look at comments. We'll take a look at hello world and indentation, how to do input, multi-line statements, and multiple assignment. Okay, so let's take a look at the first one here, which is on comments. And so, as you can see here, the pound or the hash symbol is used to indicate a comment. Here's another comment. That's a single line comment, so it only goes up to the end of that line. So if you have multiple lines, you could start each of those lines with this hash or pound symbol. Or as you can see down here, you can use triple comments. And there's two flavors of that. There's the triple double quotes and the triple single quotes. And these are technically not actually comments. They're actually literal strings, multi-line strings. But as we'll see later in the course, you can, if you use one of these triple quoted strings as the first thing that appears within a class or a method or a function or a module, we'll talk about what all those things are later. But if you do that, then this becomes a docstring. And a docstring actually becomes a property of that object. So if it's a function, it becomes a property of that function. And you can programmatically access it. And quite often, programming tools can also access it. Some development environments, for example, will display that string as a tooltip. If you put your mouse over a particular identifier within a source code editor, it can use that. In this particular environment we're using, it's a very simple environment. It doesn't actually provide that, but just be aware of the fact that these so-called docstrings are actually pretty useful. So here we see an example of a string that appears at the right-hand side of a statement, which is also a possibility. Okay, so let's close that. The next thing we want to take a look at is a simple little example called Hello World. Usually the very first code example that anyone ever sees within a programming language is Hello World, and so this is just using the print function to take a literal string. In this case it's a string within double quotes. We'll see later that you can also define strings within single quotes, and we've already seen that we can define them within triple quotation as well. This is just going to display the output Hello World. So let's just run that to see that that works. And there's the output, hello world. Okay, great. The next thing we're going to take a look at is this one on indentation. And this is basically a simple little example to show how indentation is used in Python syntax. Many other languages use either curly braces or special keywords to indicate the beginning and ending of a block of code. So for example, C, C++, Java, C#, they use open and close curly braces for this purpose. Python doesn't do that. What it does is it has a more rigid kind of fixed layout. And so for example, here's an if statement. So if this Boolean expression is true, in other words, if this variable is equal to, this double equals is a comparison operator. So if this is equal to 0, then we're going to execute this code. If it's false, then the else gets executed and we display that. So we're basically just doing the same thing. It's kind of silly in this example to be doing the same thing. Probably it would make more sense to put something like this. It doesn't really make a lot of sense to have exactly the same output in either case. So what this is doing is that if it is equal to 0, we're going to say that 0. If it's not equal to 0, it's non-zero. So let's try running. And by the way, we're also generating a random number in a range of 0 to 1, inclusive. So let's try this out. We'll run it. And it says non-zero. Okay, try running it again. It says non-zero. Try it again. Non-zero. So looked like we were getting the same thing over and over again. Well, it's a random number generator, so you can have an arbitrary number of, a sequence that comes up heads or comes up tails. But eventually we did get a 0 output. But obviously this is a random number, either 0 or 1, and it's either equal to 0 or it's not. Now the main thing that I really wanted to focus on here is the indentation. So we say if, and then after the Boolean expression, a colon, an else, and then a colon. It's really this indentation that marks this as a block of code. Now we only have one statement in here, but if you have multiple statements, as long as they're all indented the same amount, in this case it's 1, 2, 3, 4. So the standard convention that most people use is 4 spaces for indentation. Doesn't have to be, but what does have to be is that it has to be consistent. So all the code within a particular block of code has to be indented the same amount. And there are more complicated examples that you can find where you see multiple nesting levels of blocks. And in each case, each nested block will be moved over to the right by an additional 4 characters. So keep that in mind, that indentation is important in Python. Okay, so the next thing we should probably take a look at is input. And so here we use the input function that prompts the user to enter something. This \n is an escape sequence that indicates that we want a carriage return. And so then we enter the data and we take that string and we display it. This print function takes a literal string, and then this % is a format operator indicating that this string type variable will be placed into the format string here. So it's going to say hello, and then this %s is going to be replaced with whatever the user had entered, which is what the variable name refers to. So if we run that, it prompts us what's our name, and I put my name in, and it says hello Peter. Okay, so very simple little example showing how to do input. We'll see other more complicated examples where we deal with data types that are other than string, for example, later. Okay, so that was the input example. The next one I wanted to show you is multiple line statements. Now, this is not very typical, not very common, what we see here. This is actually not all that common either, but you do see it from time to time. What are these things? Well, sum equals 1 plus, and I'm breaking it onto a new line. If you want to divide it across multiple lines, you have to use a \/ to indicate that this is not a real carriage return. It's just there for formatting purposes in our code. But the expression 1 plus 2 plus 3 is all actually contained within a single logical line of code. Physically it's broken up, but the \/ mean put it all back together and treat it as a single line of expression. And that gets around the fact that these spaces here are not actually to be interpreted as indentation at all, but just a continuation of the string. So that's what we refer to as multi-statement line. And you can also have multiple statements in a single line, as long as you separate them with a semicolon. Now you don't see this very often, but it's worthwhile for you to know about just in case you ever do see it, so you'll understand it. So here's a call to the print function, and then here's another call to the print function, and let's try running that. And sure enough, we see that this first print of sum 1 plus 2 plus 3 gives us 6, and then this one here, it has these two print statements. And you'll notice that the two print statements appear on separate lines of output. That's because when you use the print function, there's an implied carriage return at the end of the line. A little bit later on, we'll see how we can format strings, use print functions to do other things. Perhaps we don't want it to have that default carriage return on the end of the line. In any case, that's basically how that one works. And the next one is multiple assignment. And most languages don't support multiple assignment. Well, I shouldn't say most don't. Some do, some don't. For example, C and C++ do. But here we have A equals B equals C equals D. That basically that's assigning 42 to D, which is in turn assigned to C, which is in turn assigned to B, and in turn assigned to A. And it just, all of them are now 42. And we'll see later on that you can actually do interesting things like X, Y equals 1, 2, and then we can let's see what that looks like. So you see 1 and 2 are being assigned. And so what's happening here is that these two numbers, we don't need spaces, they don't have to be the same on either side, but basically 1 is assigned to X and 2 is assigned to Y, all in one. And you can even have X comma Y equals Y comma X, which is a swapping type of a capability. So let's move on to the last example here, which is the pass keyword. And so here we're defining a function. We'll talk about how to define functions. Basically, a function is something that can be implemented one place and given a name, and then called from another place by that name. And in this case, the empty parentheses indicates that this is a function that doesn't take any parameters. We'll see later that you can define functions, give it any name you want, and specify any parameters that you want it to receive. And we can use the return keyword to return a particular expression or value from that function. I'm not really showing any of that. This is the bare bones example here, and I'm not showing how to call it. But the syntax of this actually requires that we have something here. So if I chop that out and try to run it, what do we get? It's invalid syntax. It's seeing an EOF, an end of file. And that's a problem. So I'm going to Control-Z that. This pass doesn't do anything, but it's a placeholder just to satisfy the requirements that the syntax dictates that we must have something there. And so by putting that there, it avoids the unexpected end of file while parsing. Now when we run it, it's not going to do anything because we're not telling it to do anything, but it does run, it's correct, the syntax is valid. That's the point. And we'll talk about this again later, but basically, this is used in situations where you're developing code, you're rapidly creating a whole bunch of functions or whatever, and you don't necessarily have time to get around immediately to implementing everything. So what you do is you put pass, pass, pass everywhere, and so it patches it all up so that it's syntactically valid. It doesn't actually do anything, but later on you'll get back into it and you'll get around to fleshing out the details on that skeleton and put in the implementation of pass. So think of pass as a keyword that's typically used on a temporary basis to just satisfy the syntactic requirements of the language. Okay, so we're going to take a look at some of these other examples soon, but that's it for this demonstration.